Hi everyone, I will be demonstrating a Spotfire integration with WellBase, and I will be showing how we can perform data analysis and QC with Spotfire WellBase integration. GeoGraphix plugin for Spotfire configures automatically when we launch WellBase. For successful configuration, Spotfire client should be installed on the same machine which has GeoGraphix. Spotfire server can be installed anywhere on the network. However, a Spotfire client should be on the same machine. As I launch WellBase, I get the message for configuring Spotfire. Over here, I got a message that is asking me for configuring GeoGraphix plugin for Spotfire. Also, I need to make sure that all the running instances of a Spotfire Analyst are closed so that I can configure GeoGraphix plugin for Spotfire. I press yes to this message, and here I got the message that my GeoGraphix plugin for Spotfire has configured successfully. In WellBase, we have Analytics drop box in the Tools tab that allows us to create a new template or open an existing Spotfire template. A Spotfire template is a DXP file which provides a predefined set of visualization for viewing data. These visualizations could be a combination of bar graphs, scatter plot, heat maps, data tables, filters, and any sort of data diagram that help us in examining any type of data. For the new templates, we have three predefined set of templates. We have the well data QC template, which is useful for analyzing basic well data, which is mostly combination of well header data and the formation data. The DST recovery template is useful for examining DST records within the specified zones. The new template is useful for examining data coming from any type of data table that resides in the database. In the new template, well header data table is already loaded. I can add any type of data table to the already existing well header table and join them in Spotfire. I will now create a new template and load data in the new template. Let's name it as Analytics Webinar Template. And open it in Spotfire. I need to get the credentials for launching a Spotfire client. The server information is already provided. You can see the Spotfire server is at a different location and a Spotfire client is installed on my machine. Before loading the data in the template, it's important to note that all the templates which are created in Spotfire via GeoGraphix are saved in the currently active project. So the Analytics Webinar template which I just created, it's only created within the currently active project, and I cannot access this template outside this project. To load the data from any data table, we need to go to Data Canvas. In Data Canvas, we can see that well header table is already loaded. I will now load the well formation table. Data from well formation table will be added as additional columns in the well header table. Right now, there are 50 columns in the well header table, and when I add the data from well formation table, we will see that the number of columns will be increased. For loading the data, we have to select the GXDB data source. As the GXDB data source is coming from ODBC data provider, I have to select the loading of data from ODBC data provider. I have to do the configuration, select the GXDB server, and in this way I can see all the data tables that resides in GeoGraphix database. The choice of data table, as mentioned earlier, is well formation table. I will select the well formation table, give the data source name, and load the columns. Now if I want to change the way with which additional columns of well formations table are added in well header table, I can do so by going to settings for edit columns. Over here I can see that the two tables are joined together using the left outer join. I can change the type of join to any of the desired join. However, in this particular case I will be using left outer join. This is because there cannot be any formation picked that does not have a well ID, and as well ID is the column of well header table, therefore left outer join is the right choice. Now I have loaded the data. Once the data is loaded, we will see that the number of columns over here will change, and they will probably be increased as the columns from the well formation table will be joined with the well header table. Here we can see that there is a graphical representation over here. The well formation table has been added, and also the number of columns is changed to 100 columns, and all the columns that are coming from well formation tables are mentioned over here. So in this way we can load different data tables from database, join them together and load data from them. We can also load data from database views. I will now create another Spotfire template in which I will load data from a database view. Let's go to WellBase, create a new template, give it a name of database view and open it. Database views can be created in GeoGraphix database. In the new template we can see that well header table is already there. I will now add additional column to this table from database view. To load the data from the database view, I have to set the configuration again because this is a new template. Over here we can see that database tables are listed in uppercase, database views are listed in mixed case. So all the items which we are seeing right now are basically database views. I have already created a database view from well header and well formation table. Let's give this database view a data source name and load data from it. Since this is a database view which is created by joining well header table and formation data table, therefore I have not set the join type when I have loaded data from this database view, because the join was already created when I created the database view. Another advantage of loading data from database view is that the column name can be set by our choice, so that the column names are much more readable, they are much more understandable. Now the data has been loaded from database view. Formation view is graphically represented over here. The number of columns is changed to 137, previously it was 50. The well ID column that is coming from well header table, let's see that the columns from formation data table are here or not. So over here all the columns which are being viewed are basically from formation table. This is the formation FM at TD is from formation data table. We have the wild boar angle, lithology, age code, strat column. So all the columns that are from formation data table and the well header table are there. Now the data is here. Let's create a visualization to do the data analysis and QC. For visualization, first I need to add the table. I will also need a histogram or a bar chart, pre-map and map chart for determining the location of the wells. The visualization which I will now create will help me in determining the wells that do not have the datum elevation. I will create a filter of those wells in Spotfire and activate that filter in WellBase. Now let's do a little bit of settings to this visualization so that it looks more readable, looks more attractive. I have to set the bar chart on the basis of datum elevation. So on the x-axis I need to select datum elevation because this is the field on which I want to determine the wells which have no datum elevation. Also for the color I need to select datum elevation as well over here. No need to sum it right now, and appearance has to be side by side. These are just little bit of settings to the visualization that adds readability to it. Okay, now the wells which I want to determine are those wells that have no datum elevation. Over here we have an empty field in the tree map. I select this. For wells that have missing datum elevation to appear in the table, I need to activate the marking. So this is what I have done. Now when I select any field in the tree map, the wells corresponding to that particular field will be highlighted in the map view and will be listed in the well header table. So I have selected empty field. I right click on the table, I press the create WellBase filter, and this operation will create WellBase filter. So these are the wells that have no datum elevation. So wells with missing datum elevation. So this is how I create a filter from Spotfire in WellBase, and now once the filter is created I will activate that filter in WellBase. So filter is created. Let's activate it in WellBase. Go to home, activate the filter, select the filters wells with. So wells with missing datum elevation. Yeah, it will be down over here somewhere. So here is the filter which I just created in Spotfire. Let's open it and see if. So here we have missing datum elevation record. So these are all the wells that have no datum elevation. Now I would like to make this tree map visible on the basis of county so that I can determine how many wells belong to which county and what is the relationship between counties and wells that have datum elevation between 100 to 200, because the basin on which I am working is Eagle Ford Basin, and I would highlight those wells that have datum elevation below 200. So let's see how Spotfire can help us quickly determining wells that specify this criteria. Let's do some twitches to this tree map. Let's group by hierarchy. In the hierarchy I will set the hierarchy as county because I want to determine those wells that belong to particular county and have datum elevation of below 200. Let's color the scheme with something a bit more attractive. So the county is here. Add a color scheme. I already have a color scheme. Let's add it. So this is a color scheme. Basically in Spotfire we can load different color scheme from already created libraries. I had a library which I created earlier, so I will use that. So I would also like to size this thing by county because county is the field I am doing analysis, and this will be the count. So here I am getting the size of these counties on the basis of their the wells that are in that particular county. I think I have done all the needful settings. Now Let's do few of the settings for the histogram so that histogram is more readable. Data is fine, I guess. Appearance is side by side tracks. Okay, value access row count. Row count is basically a number, so I have to select it over here. I want to show the zoom slider as well. Zoom slider, yes, I want to show the zoom slider. For the value access, I want to show the grid lines. Okay, and then for the color is on the basis of data elevation. That's fine. I would like to split the data on the basis of subsets, and if there is anything else I need to do, yes, I have to select this option. So to limit the data to limit that data that does not exist in the current filter. Tooltips are all good. Anything else I need to do? Row count is fine. The table efficient bin. I think this is all what I need to do at this moment. Now let's limit the data, since I want to determine those wells that have data elevation of below 200. So this setting is nice, and then increase the number of bins. So over here I can see at this portion there are like 235 wells that have data elevation of less than 200 feet. So let's select this, and you can see that they belong to different counties. Now let's create a filter of these wells and open them in WellBase. Wells with data elevation of 200 and less. Okay, now let's create a filter and activate this filter. Filter is there. I have to deactivate the previous filter, activate the new ones. So this is wells with data elevation of 200 and less, and activate this filter. So over here I can see the well that have data elevation of less than 200. In this way we can create filters of different types in Spotfire. We can see that we can very easily create visualization in Spotfire. In the tree map, if I want to change the hierarchy and I want to determine wells that belong to different operators, I can simply select the operator field, and here I can see all the operators. There are vast number of operators. If I want to view the wells that belong to different operators, I can very easily do that by simply clicking on that operator, and all those wells will be listed in the table, and I can create filter of these wells from this table. Also, if I want to view the status of different wells, all I need to do is to select the status field. So here all the wells that are producing gas can be listed, all the wells that are producing oil can be listed by simply pressing the desired field. So in this way we can create different visualization in Spotfire. We can view different types of wells from Spotfire in WellBase, and the data analysis and QC in Spotfire with WellBase integration is now very simple. It's very handy. Now let's do formation analysis with Spotfire visualization. For formation analysis, I will be using a scatter plot to determine formation outlier. Let's delete few visualizations from here. So tree map is not required at the moment, histogram is also not required. I will be adding a scatter plot, and also I don't need a map chart as well. Let's add the scatter plot. Before I add a scatter plot, I would like to emphasize on one thing. Previously, as we have seen that the database view from which data has been loaded in this visualization consisted of joined two tables of database, that is well header table and formation data table. Now in this single visualization we are basically adding data from two different data tables, and on the scatter plot I will be using formation formation data table that is on the x-axis, I will be assigning form alias field. On the y-axis, I will be using top MD field. In this way, I can very quickly determine any formation data outlier that exists in the database and quickly correct that outlier value. Now let's do few settings of the scatter plots. First, on the x-axis, I need to assign the form alias field. We can see that the fields from the formation data table can be viewed in the visualization. On the y-axis, I have to use the top MD field. Color should also be on the basis of formation. What else I need to do over here? Marker by row number, that is also fine. I need to decrease the size because this size is so big. This is good. Also on the x-axis, I need to show the zoom slider because there is a high number of formations and it is very cluttered, and the label should be vertical so that at least I can see their name. Now this is all good. I think I do need a tree map over here. Previously I thought I don't need tree map here, but we need a tree map because we want to determine the formation names, and we also need to know the wells that belong to those formation names and send those wells in WellBase. So let's do a little bit of settings for the tree map so that it represents the formation. Color by needs to be on the basis of observation number. I do have a color scheme for formation analysis. Let's use that scheme. This is a scheme I've created previously. So size by has to be also on the basis of observation number, and hierarchy should be form alias because I want to know the name of formations that have any outlier point or which I want to view in WellBase. Okay, now this looks good. Now let's see over here, we have a formation outlier for Buddha. Let's zoom the y-axis because it is too heavy. Okay, now this is much better. So over here we have a Buddha formation and its top MD is 40,000. Now this is definitely an outlier value. Let's view this in WellBase and correct this value and have the updated data in Spotfire. So we see that this is a Buddha formation, it is highlighted. Let's click on this well. Now we have the implementation that we can directly view a well from a Spotfire in WellBase without creating the filter. Now this operation will create a special filter, but special filters are definitely temporary filters. So if you want to create a filter, it is always recommended to create a name filter. However, if you quickly want to analyze a few wells and collect their data, then this opening of wells directly from a Spotfire in WellBase is recommended. So we see that the TD of this well is 13,200. We are seeing that this is a special filter for, and only one well is over here. So the TD is 13,200, whereas the Buddha formation outlier is at an MD of 40,000. This is definitely incorrect. Let's collect it, and I do need and I do know the value of this the Buddha formation in this well. It's 9,200. Now this value is saved. Now let's load this this data again so that the outlier is removed. Now I will reload the data, and we will see that once the data is reloaded, this outlier will be removed. Now formation outlier has been removed and everything is much more visible. The other thing in Spotfire we can do is we can very quickly determine the wells that belong to different formations. So if I want to create a filter of those wells that have Eagle Ford formation, I can simply select the Eagle Ford area in the tree map. We can see the table is now corresponding to only those wells that have the Eagle Ford formation. Simply right click it, create WellBase filter, and in this way WellBase filter will be created. Also, if we can see that once the area of a particular formation is highlighted in the tree map, the corresponding spots on the scatter plot are also highlighted. Likewise, when I select the wells in the scatter plot, the corresponding area in the tree map is also highlighted. So here I have selected few markers in the scatter plot, and the areas of formations to which those markers belong are highlighted in the tree map. So Buddha formation is highlighted, Austin Chalk formation is also highlighted, and the wells that belong to these formations are listed in the table. So now if I want to filter out those wells that have formation tops ranging from 0 to 1000, I can simply select their markers in the scatter plot. So I have selected Buddha, Austin Chalk, and 3 or 4 more formations. Like I said, the wells in the table now correspond to the selected items in the scatter plot. I can simply create a filter of those wells that have formations which are ranging within the range of 0 to 1000. MD between 0 to 1000. I save the filter, and then this way filter has been created. And as previously shown, I can simply activate the selected filter in WellBase. So in this way we can perform different QC operations on the basis of formation data with Spotfire WellBase integration. Now let's examine zone data in Spotfire. Let's open the DST recoveries template. This template allows us to analyze DST data, which includes pressure data, pipe recovery, chamber data, and other type of DST data within the zone. What's happening in the back end is we are providing all the zones to the Spotfire. However, only those zones are shown in the tree map that have the DST records. Let's open the DST recoveries template. Over here in the tree map, we are seeing all the zones that have the DST recovery data. I select a particular zone, which is the well zone, and now if I want to save an attribute from Spotfire in ZoneManager, I can easily do so. For example, I have all the DST parameters that include start pressure, end pressure, recovery amount, choke description, and all sort of DST records. Now if I want to save this end pressure attribute in ZoneManager, I can simply click on this attribute, add it to ZoneManager, select it from the attribute name drop down. Please note that the attribute which I want to save from Spotfire should be first added in ZoneManager so that it appears in the attribute name drop down list over here. I select the attribute, I press OK. I do want to override the existing values if there are any, and in this way attribute will be saved in ZoneManager. Now let's open ZoneManager and see the attribute values. So over here we are seeing that all the attribute values of end pressure are updated in ZoneManager. So this is how we can analyze DST records within the zone in Spotfire. This concludes all the well pros. That's all we have for today, folks. Thank you for attending.